A plus B whole square is A square plus what?
The A square plus B square plus
Plus
2AB.
B square. We should write the expansion in form of decreasing powers of A and increasing powers of B. Okay? Again, if you write the expansion of A plus B whole cube, what it could be? It is A cube plus what? 3 power of A decreases by 1. A square B plus 3A B square plus B cube. Is that clear to you? Similarly, we can expand others also. But if you want to expand A plus B whole to the power 4, what it could be? To expand it, first write A plus B whole square, then whole square. A plus B whole square, we know that is A square plus 2AB plus B square, then again whole square. Then use A plus B plus C whole square, that is A square whole square plus 2AB whole square plus B square whole square plus 2 into A into B plus 2 into B into C plus 2 into C into A. Okay. So it is A to the power 4 plus 4A square B square plus B to the power 4 plus 2 to the 4 A cube B plus 2 to the 4 AB cube plus 2 A square B square. Now if we arrange them in decreasing powers of A to the power 4 plus next will be 4A cube B plus 4 plus 2 6A square B square plus 4AB cube plus B to the power 4. Is that clear to everyone? It is A plus B whole to the power 4. Okay, understood? So remember, A plus B whole square is A square plus 2A plus B square. A plus B whole cube is, but you cannot find the product above this power. So to find them and to find the expansion of the binomial having the powers, larger power, we must use binomial theorem. Okay. So this is not the binomial theorem. This is only the introduction to it. Now, what is binomial theorem? So let's discuss that. If it is A plus B whole to the power n, where n belongs to a natural number, A plus B whole to the power n will be nc naught A to the power n B to the power 0. So maximum power of A. And what is the meaning of nc naught? I am going to discuss that also. First write only nc naught, then nc1 into A to the power n minus 1 into B to the power 1. So next is nc2 A to the power n minus 2 B square. Okay. These all are the binomial coefficients. And finally, the last is nc naught A to the power 0 B to the power n. Is that clear to you? Now, what is the meaning of NCR? So, before we study NCR, whose formula is factorial n upon factorial r into factorial n minus r, we will discuss more about them in the topic permutation and combination. Okay, but what is the meaning of this factorial? So factorial means if we write factorial 2, so remember it is 2 into 1. If we write factorial 3, it is 3 into 2 into 1. Now factorial 2 is 2. Factorial 3 is 3 into 2 into 1. 3 to the 6. Factorial 4 equals to 4 into 3 into 2 into 1. 4 to the 12 to the 24. Factorial 5 is 5 into 4 into 3 into 2 into 1. So it is 5 4 the 20, 3 are 62 the 120. Is that clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
So now, if we write a factorial of n, what it should be, what it could be, it starts with n, then 1 less than n, n minus 1, n minus 2, and finally 3 into 2. Is that clear to everyone? And NCR is factorial n upon factorial r into factorial n minus r. Okay. So now let's discuss how to use this formula. If we have to find 3C1, use this formula of NCR. Factorial 3 upon factorial 1 into factorial 3 minus 1. That is factorial 3 over factorial 1 into factorial 2. Now, if we expand this factorial, it is 3 into 2 upon factorial 1 is 1 only and factorial 2 is 2 into 1. 2 cancelled out, so it is 3. Is that clear to you? Understood?
Yes, sir. Clear. Yes,
Yes,
sir.
sir.
Can you now find the value of 5C2? Tell the value of 5C2.
Sir, 10.
Is it
10.
10? Factorial n upon factorial r into factorial n minus r. Factorial 5. 5 into 4. Remember, after this we will have factorial 3, na? 3 into 2 into 1. And we already have factorial 3 at the denominator. And value of factorial 2 we know that is 2. So factorial 3 cancel out to the 4. 5 to the 10. So value of 5 C2 will be 10. Understood, everyone? Now can you find the
Yes, sir.
3? What is the value of 63?
No, sir, solving.
Okay. Factorial 6 upon factorial 3 into its calculator, you have seen that this factorial 6 is written in like this exclamation sign. Okay. So factorial 6 means 6 into 5 into 4 into factorial 3 over factorial 3 into factorial 3 is 6. This 2 cancelled out, 6 cancelled out, 5 4s are 20. Is that clear to everyone?
Yes, sir.
Yes, sir.
Okay. So have you understood the meaning of NCR?
Yes, sir.
Written all the formulas?
Yes, sir.
Yes, sir.
So after this, let's now discuss how to expand a binomial expansion. Like, if you want to expand x plus y whole to the power 6, what will be the expansion using the formula? Value of n is 6. So we write what? And always remember factorial 0 equals to 1. Okay? Factorial 0 equals to 1. Okay?
Yes, sir.
Now, x plus y whole to the power 6. 6c naught into x to the power 6 into y to the power 0 plus 6c1 into x to the power 6 minus 1 into y to the power 1 plus next is 6c2 into x to the power 6 minus 2 4. Means powers of x decreases 1 by 1 and powers of y increases 1 by 1. X to the power 6, x to the power 5, x to the power 4. and powers of y increases one by one. Y to the power 0, y to the power 1, y square 63 x to the power 3 by 3 by cube. 63 x cube by cube. Next is 64 x to the power 1 x square. Power of x again decreases by 1 x square and power of y increases by 4. So it becomes y to the power 4. The next is 65 x. Power of x again decreases by 1. Power of y again increases by 1. Plus 66 into x to the power 0 into y to the power 6. Is that clear to everyone?
Yes, sir.
Always
Yes,
remember,
sir.
whenever there is 0 in the suffix, value will be 1. We can calculate it. It is 60 naught. 60 naught means on the formula NCR factorial n upon factorial r into factorial n minus r. Factorial 0 is 1. Factorial 6 upon factorial 6 is also 1. Is that clear to you? So always remember a formula, just like a formula, NC not equals to 1 always. Okay? NC not equals to 1 always. N is prefix, 0 is suffix, C is in the main term, value of C is 1 actually. Okay? When suffix is N, prefix is 0. 1 into x to the power 6. And we know that value of y to the power 0 is also what? Value of y to the power 0.
The 1.
1.
Sir,
So the
1.
first term is x to the power 6. Okay. Now we will find 6c1. And for this also remember 6c1 equals to factorial 6 upon, is it visible? Now it is visible. Factorial 6 upon factorial 1 over factorial 6 minus 1, that is 6 into factorial 5 over 1 into factorial 5. Factorial 5 cancelled out. So it is 6. Is that clear to you? Now remember one more formula. NC1 equals to N. Okay? NC1 equals to N.
N.
6C1 equals to 6 x to the power 5 into y. Is that clear to you? Plus, what will be the value of 62? Always, and learn one more formula for NC2 also. NC2 will be n into n minus 1 by 2. So what will be the value of 62? Can you tell? Is it not 6 into 5 by 2? 6 into 6 minus 1. So 5 3 is the 15. Is that clear to you? Now whenever you have to find NC2, use the formula n into n minus 1 upon 2. So the formula for 6C2 is 15 x to the power 4 y square. Okay? Is that clear to you?
Yes, sir.
Yes, sir.
63. What is the value of 63? Can you tell the value of 63? Factorial 6 upon factorial 3 into factorial
Sir,
3.
20.
6 into 5 into 4 upon 1 of the factorial 3 will be cancelled out, this factorial 3. Factorial 3 is also 6, 6, 6 cancelled out, so it is 20. 64, say 63 is 20 x cube into y cube. Understood? Now, what will be the value of 64? Can you find? What will be the value of 64? Can you find? Have you written these formulas? NC not equal
Yes, sir.
NC1 equals to N, NC2 equals to N into N minus 1 upon 2. Am I audible?
Yes, sir.
Yes,
Yes,
sir.
sir. Yes, sir.
My voice is clear? You have written all these formulas?
Yes, sir.
Yes, sir.
So I am rubbing it. Now, I will discuss one more formula. So, what is the formula for NCR? Factorial n upon factorial r into factorial n minus r. Okay. Can you find the formula for NC n minus r? Find this formula and then tell me. Formula for NC n minus r. Yes. What is the formula for NCn minus R?
Sir, factorial of n upon factorial of n minus r into factorial of r.
Means it is same as NCR. Is it not same as NCR?
Yes,
Yes,
sir.
sir.
Always remember NCR equals to NC n minus R, right? This formula also. So using this formula, we can write 62 equals to what?
Sir, 15.
60,
4.
4.
4.
And we know that formula for NC2 is we already have used n into n minus 1 by 2. Using that formula, we have calculated the value of 62 as 15. So there is no need to calculate the value of 64 again. We will directly use 15. Okay. 64 is 15. X square y. Is that clear to you?
Yes, sir.
Next one.
Yes, sir.
65 will be equal to 61. And we know that NC1 is n. So 61 is 6. X y to the power 5. 60 plus 6 is equal to 60 naught. Using this formula, NCR equals to NCN. And value of 60 naught is 1. X to the power 0 is also 1. 1 into y to the power 6 is only y to the power 6. Is that clear to you?
Yes, sir.
So the expansion of x plus y what to the power 6 is x to the power 6 plus 6x to the power 5 into y plus 15x to the power 4 y square plus 20x to y cube plus 15x square y plus 6xy to the power 5 plus y to the power 6. Is that clear to everyone?
Yes,
Yes,
sir.
sir.
Any doubt?
Yes, sir.
Any doubt?
No, sir.
No, sir.
Now count the number of terms in this. Count the number of terms in x plus y whole to the power 6. How many terms are there? 1, 2, 3, 4, 5, 6, 7. Is that clear to you? How many terms are there in the expansion of x plus y whole to the power 6?
7
7.
terms.
Means one more than the power. Similarly, in this also, if you expand it, NC naught is the first, NC1 is second, NC2 is third. So NCn will be n plus 1n. Is that clear to you? So number of terms, remember, number of terms in expansion of a plus b whole to the power n is always n plus 1. Means one more than the powers of n. Understood? Number of terms in expansion of a plus b whole to the power n is always n plus 1. Is that clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Written everything?
Yes, sir.
The first question is number of terms is px minus 7 by y square whole to the power 8. So number of terms will be one more than the power. That is 8 plus 1 equals to 9. Second, number of terms in 1 plus 2x plus x square whole to the power 7. We know that this is 1 plus x whole square and then whole to the power 7. That is 1 plus x whole to the power 7 to the 14. So the number of terms will be 14 plus 1 equals to 15. Okay. Then second, in one more question, 1 plus 3x plus 3x square plus x cube whole to the power 5. So what will be the expansion of this bracket? Is it not 1 plus x whole cube? Then whole to the power 5 equals to 1 plus x whole to the power 3 5s are 15. So the number of terms equals to 15 plus 1 equals to 16. Is that clear to you? Understood everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Now let's discuss one more important question. How to find the number of terms in a minus b plus c whole to the power 6. As we know that we cannot expand it as it's a trinomial. है ना? Is it visible now?
Yes,
Yes,
sir.
sir.
So we will assume it to be x. This one. Put a minus b equals to x. Okay. So it will be x plus c whole to the power 6. Now it's a binomial. Okay. Now expand this binomial. We have to expand this binomial. There is no other way to find the number of terms without expansion. X plus c whole to the power 6. What will be the first term? 6c naught x to the power 6 c to the power 0 plus second term 6c1 x to the power 5 c to the power 1. Third term 6c2 x to the power 4 c square. Next is 6c3 x cube c cube plus 6c4 x square c to the power 4 plus 6c5 x into c to the power 5 and final 66 x to the power 0 c to the power 6. Is that clear to you? That's why I'm telling you how to apply equal to sign always, so that it is clear that this is only one step. Now what is the value of 60 naught? We are not requiring that. X is, now put the value of x. It is a minus b to the power 6 to c to the power 0 is 1 only plus 6c1 x is a minus b whole to the power 5 into c plus 6c2 a minus b whole to the power 4 into c square. Is that clear to you? Plus 6c3 x cube, as we have to find only the number of terms, so don't expand beyond this. Plus 6c4 a minus b whole square c to the power 4 plus 65 a minus b to the power 1 c to the power 5 plus 66 a minus b whole to the power 0 into c to the power 6. After writing this, now we will write the number of terms. In expansion of a minus b whole to the power 6. Now if we expand this, how many terms will it have? Can you tell the number of terms in this expansion?
So 7.
A minus b whole to the power 6.
So 7.
7 plus in second expansion, and c is single, so on multiplying these which are outside the bracket we will get the 7 terms only. Similarly in this, how many terms are there?
So 6.
6,
In this
The six,
5,
5.
the five,
5,
and in this
4.
4,
the four,
plus 3
the
plus
3,
2 plus finally a minus b whole to the power 0 is 1. So total number of terms is 6 plus 7 plus 5 plus 4 plus 3 plus 2 plus 1. Sigma n into n plus 1 upon 2. 7 4 28. Is that clear to you? So the total number of terms will be 28. Understood everyone?
Yes, sir.
Yes, sir.
yes, sir.
yes, sir.
Correct. You have written this?
Yes, sir.
Is that clear to you?
Yes, sir.
To the power n is nc naught x to the power n a to the power 0 plus nc1 x to the power n minus 1 into a plus nc2 x to the power n minus 2 into a square plus ncn x to the power 0 a to the power n. With this we have studied already. This is the binomial theorem. Now if we change this plus to minus, this minus a goes with this a in all the terms. Minus a to the power 0, minus a to the power 1, minus a whole square, and so on up to finally NCN x to the power 0 minus a whole to the power n. Understood? So NC naught, this minus a to the power 0 is a to the power 0 only. But this minus a to the power 1 will become a. This minus is multiplied to this plus. So there will be alternate plus and minus. Plus what will be the next term? NC3 x to the power n minus 3 into a cube. Is that clear to you? Understood?
Yes, sir.
Yes, sir.
And finally, which term we are getting? It is minus 1 to the power n, which is the symbol, which is it, either it is positive or negative. If n is even, then it will be positive. If n is odd, then it will be negative. Okay, so this is the expansion of x minus a whole to the power. Alternate plus minus plus minus plus minus. Okay. Now if we add these two expansions, means x plus a whole to the power n plus x minus a whole to the power n.